Hi, this is Coach Dorf. Now we're going to look at a homework problem from section 5.2. This problem deals with the definition of the integral. So it's connecting the idea of the limit of a summation with the idea of an integral. So in this problem, we're given this limit of the sum I equals 1 to n of x sub I square root of 1 plus x sub I cubed times delta x. So the first thing we need to know here is the definition of the integral. And what is that? That says that this limit as n goes to infinity of the sum I equals 1 to n of f of x sub I delta x equals the integral from a to b of f of x dx. And in this case, we know that delta x equals b minus a over n, and x sub I is going to equal a plus I delta x, okay, which you could also write as a plus I times b minus a over n. All right, and this is meaning that we're using then the right endpoints when we do this type of this definition here. Okay, all we need to do is translate what we're given to the form of the integral. So again, we start with the limit as n goes to infinity of the sum I equals 1 to n x sub I delta square root of 1 plus x sub I cubed delta x. And that's in the definition, that represents as part the limit of the sum I equals 1 to n of x sub I delta x. And to solve this one, what we need to find the following. We need to find a, what is a equal, what is b equal, and what is f of x equal. Now, we're given the interval, so that's really helpful. We note that we're given the interval 2 to 5. Well, how does that help us? Well, this implies that A is the first point of the interval and B is the second point. So we know that A is 2 and B is 5. Next, I'm going to look at my function that I have here. Remember, I have this function, and that corresponds with this. So I need to look at that and try to figure out what f of x is. Well, what am I going to be looking at that? And I'm going to say, like to me, f of x is x times the square root of 1 plus x cubed. Because now if I put in f of xi here, that's going to be xi of 1 plus x of I cubed. And that's what we have right up here. So it works. So what do I have again? I have a equals 2, b equals 5, and f of x equals x square root of 1 plus x cubed. And so in my integral, the original limit problem of the summation is equal to the integral from a to b of f of x dx. So I just substitute those values in and I get integral 2 to 5 of x square root of 1 plus x cubed dx. And that's my answer. All right. Now, once you understand this idea, it's really straightforward, but sometimes it takes a little bit of time. So let me do another example here. All right, suppose now this one I had same problem, same idea, but use the limit as x goes to infinity, sorry, as n goes to infinity of the sum I equals 1 and 5 x of I star cubed minus 4 x of I star delta x, and you're given the interval from 2 to 7. Okay, so how do I do this? Again, we want to find the integral from a to b of f of x dx. So we need a, b, and f of x. Okay, we're the interval from that, it's from 2 to 7. So this is going to tell me a is 2, the first point of the interval, and b is 7. And now I just have to figure out what f of x is, right? Well, I know that here, this part here, 5 x of I star cubed minus 4 times x of I star, that's going to be f of x of I star, because that comes from comparing the limits, just like we did in the previous problem. And so that's going to suggest to me that f of x is 5x cubed minus 4x. And so now I can use all of these ideas, put them together, so that my limit as n goes to infinity of the sum I equals 1 to n 5 x of I star cubed minus 4 x of I star delta x on 2, 7 is going to equal the integral from a to b of f of x dx, which is going to equal the integral from 2 to 7 of 5x minus 4x. dx. And that's my answer there. Now, let me do one more example, but do the other way around. So an example going the other way around, or in other words, going from the definite integral to a limit of a sum, which is known as the Riemann sum. Okay, so here's the thing I do. Write the integral from 2 to 5 x squared plus 1 over x dx as a Riemann sum. And again, this is a German word. Riemann is a German name, and if you pronounce the E, when you have a word that's spelled IE, you pronounce the E first. So what do I do here? The integral from a to b of f of x dx is going to equal the limit as n goes to infinity of the sum I equals 1 to n of f of x sub I delta x. That's the definition of the integral. And to write for my Riemann sum, so to write Riemann sum, we need, what do we need? Delta x. We need x sub I and f of x sub I. All right. From the integral to the 5 of x squared plus 1 over x dx, we know that a is 2, that comes from here. B equals 5, because that comes from here. And f of x is x squared plus 1 over x, because that comes from there. And from the definition, we know that delta x equals b minus a over n, x of I equals a plus I delta x, which is a plus I b minus a over n. Where does that come from, that definition? That comes back to the very beginning here somewhere, right up here. That comes from this part right back here in the beginning. Okay, these are called green part. That's where it all comes from. So we need to work with these things. So what's delta x? So that's going to be b sub a. We know that b is 5 and a is 2, like that. And those again come from up here. So I get 3 over n for delta x. And x sub I is going to be a plus 1 delta x. So that's going to equal 2, because that's the a value, plus 3 over n. And that's often written as 2 plus 3i over n. All right, so there's my delta x, and this is my x sub I. But finally, remember, what do we need? We need it up here. We need these three terms, delta x, x sub I, and f of x sub I. So we just need to get f of x sub I. So what's f of x sub I? Well, remember to do all my colors here. Here's f of x. So bring that down here. We're going to put in x sub I, which is this. Okay, so I'm going to 2 plus 3i over n squared plus 1 over 2 plus 3i over n. That's what f of x sub I is. So then finally, I can now finish the problem. So the integral, our original problem, back here, the integral from 2 to 5 of x squared plus 1 over x dx equals, as a Riemann sum, limit, as n goes to infinity, of the sum I equals 1 to n f of x sub I delta x. So that equals the limit, as n goes to infinity, of the sum I equals 1 to n, 2 plus 3i over n squared plus 1 over 2 plus 3i over n, all times delta x, which is 3 over n. And that becomes my answer. Again, this part here in red, that came from down here, and this part in red came from that right there. All right, that's how you can go back and forth between the Riemann sum and the definite integral.